Page 77. Find the circumference and the area of each circle. So here we have a circle with a radius of 5 centimeters. So area is pi times the radius squared. Again, I am using a calculator, so I encourage you to do the same. Area is pi times 25. And that's going to be 78.5 square centimeters. And then circumference will be pi times diameter, or 2 pi r. You can use that as well. So C is pi times 10. So C is about 31.4 centimeters, not square centimeters, linear centimeters. And let me just remind you, circumference is this distance. Area is this distance. And remember, area is always measured in square units because you are looking for the number of squares it would take to fill up this space. Now, obviously, you can't fit squares nice and neatly in here, nicely and neatly. You would just have to estimate how many squares it would take. But area is the inside dimension. So that would be this one. And I will not color them all. It does tell us to round to the nearest tenth. I am notorious for not reading directions, so that could be important. On number 2, we're looking for area, or you can do circumference first. It doesn't matter. Area is pi times the radius squared. So pi times 11 squared, which is 121. And at this point, I'm bringing in pi, 3.14. And that's going to be approximately, all of these are approximate because pi is rounded, but 379.9 square inches. And circumference is pi d, so 3.14 times 22. Circumference is going to be, it's a little bit hard for me to multiply with pi in my head, 69.1 linear inches. And then number 3, we want the area, which is pi r squared. So pi times 2.1 to the second power, or pi times 2.1 times 2.1, 4.41, and multiply that by pi. If you round it, you're going to get 13.8 square meters. And then to do your circumference, I'm using pi d. You can do 2 pi r. I've got pi times diameter is 4.2. This will be awfully close because look how close those two are. Won't be exact, but it'll be close. 4.2 times 3.14 is 13.2 linear meters. Sasha needs to buy 1 packet of seeds for every 12 square feet in her garden. That reaches out and grabs me by the nose to say ratio and proportion. If the circular garden has a diameter of 18 feet, How many packets of seeds will Sasha need? I'm going to change color here just because this is starting to run together. So area of a circle is pi times the radius squared, or pi times 9 squared, or pi times 81, or approximately 254.34. Now, they didn't tell me to round, so I'm not going to. I need a little bit of space. If you know to divide, go ahead and do that. If you don't, you can use a proportion. You know that 1 pack of seeds does 12 square feet, and we have this many square feet. That's why it's important to use units. One reason it's important. So 254.34 gets multiplied. So 254.34 divided by 12. If you knew to divide, it's fine. That's 21.195 packages. So she's going to need 22 packages. 21 is not enough. So I'm going to go with 22. You have to round up to be sure that you can cover all the area. Max is planting a circular flower garden in the center of a lawn. He has 30 feet of fencing to go around the garden, so that's circumference. To the nearest tenth of a foot, what is the greatest diameter the garden can have without Max buying more fencing? So we are given circumference, and we're looking for diameter. We know that circumference is pi times the diameter, and we know that circumference is 30, so that's pi d. And we have some algebra here that we need to do. We want to solve for d, so anything that's not d is coming onto this side. That means we're dividing by pi, because we want to get pi out of there. So 30 divided by pi is approximately 8.82. So that's not right. I can tell by looking at it, it isn't. So let me try it again. 30 divided by 3.14. I don't know where I got that. Always ask yourself if it makes sense. 9.55. You see why I like mental math. So I'm going to call that 9.6. I don't really know why. I guess because we rounded to the tenths up above. Or you could leave it as 9.55 approximately. Number 6, we're looking at cans of frozen juice concentrate. Often have plastic strips that you pull to remove the lid from the can. The length of the strip is the circumference of the lid plus 0.25 inch. If the radius of the lid is 1.25 inches, what is the length of the plastic strip to the nearest tenth of an inch? So essentially, we're looking for the circumference of that plastic strip, but we need to be very careful with the radius, okay? Actually, we don't. We need to find the can and then add on the extra. I'm sorry, I misread that. So if radius is 1.25. Diameter would be 2.50 or 2.5. So circumference is going to be pi times 2.5. And that is not something I want to do in my head. That is 7.85 inches around the lid. And then we have to add on that extra for the strip. This is not the easiest problem I've seen in a while. 8.1 inches. And that is the final answer that we're looking for. Okay, at the bottom, we're looking at some more terms. I'm not sure that this is going to be relevant to what you're going to do, but I do want to cover this in case anyone wants to know it. A figure has symmetry when a line can divide it into two parts that are exact mirror images of each other. So symmetry relates to mirror imaging. Some figures have more than one line of symmetry. For example, a square, because it's perfect all around, it has 4 lines of symmetry. You can draw a line vertically through the center or horizontally through the center. Imagine that that black line is a mirror and you're getting a reflection on one side. And then here's a diagonal, and then you have a diagonal with a negative slope. So all of those divide that square into mirror images. The more equal something is, the more you can get symmetry from it. Squares are equal all around. They're equilateral shapes. How many lines of symmetry can you draw for each figure? All right, for the rectangle, I'm going to show you 4 lines of symmetry. And I'm going to change color every time. So we can do a horizontal. We can do a vertical. We can do a diagonal with a positive slope. And we can do a diagonal with a negative slope. So a rectangle has 4 lines of symmetry. 1, 2, 3, 4 for the rectangle. The oval, that's not a circle, it's an oval or an ellipse. Sometimes you will see this, not to be confused with ellipsis. And that may just have 1 L, I'm not sure. Those are the 3 little dots that you see in writing. An ellipse is an oval. And an ellipse has 2 lines of symmetry. You have the vertical and the horizontal. I've seen this on employment tests before, and that's why I wanted to show it to you just in case. So an ellipse has 2 lines of symmetry. How about this triangle? Now, it's very important to realize that this is an equilateral triangle. The sides are equal. And remember, the more equal something is, the more symmetry you can draw. So one way to do this one is right down the middle. That's a mirror image. So there's one. You can also go right down the middle because it's equilateral. You could cut it this way. That's 2. And then you could cut it this way. This one's going to be the tricky one for me because I'm drawing against the grain. Let me try it this way. Yes, there is the third one. So an equilateral triangle has 3 lines of symmetry. Our friend the trapezoid has 1 line of symmetry, and it will always connect the bases. It won't always. Yes, it would, I guess. 1 line of symmetry. Our parallelogram has no lines of symmetry. Do not draw this. Just look at this. If I were to go from corner to corner, if that were a mirror, those 2 sides are not reflections. Now, you could make them fit, but they're not reflecting as symmetrical. So this one has none. What geometric shape would be symmetrical for any line drawn through its center? And hopefully you will recognize this one, because what is that line called through the center of a circle? It's called the diameter. And it doesn't matter which direction you draw it, if it's passing through the center, you have infinite lines of symmetry here, because you could keep drawing these all day long and you will get infinite lines of symmetry. So a circle is the answer they're looking for. As long as it's passing through the center, not like the ellipse. The ellipse is not circular, it's oblong. But the more perfectly round this is, the more lines of symmetry you can get.